All right, so what we're going to do is continue discussing our example of the ImageStreamGang app. And now what we're going to do is we're going to talk about how completable futures are used in order to implement a different version of the same capability. So let's talk about how this is going to work. Once again, this app works the same as the parallel streams version. In other words, you give it a list of URLs to download and a list of filter transforms to apply, and it downloads the images, applies the transforms, stores the results, and then displays them. And so you can ignore the cached images, you can download the non-cached images, you can apply a list of filters to each image to transform them. These get stored in the file system on the device, and then finally it gets displayed to the user. The way this works under the hood, of course, is to use completable futures. Yes, Matt. So, okay, so the question was what file system and databases does Android use? So there's a couple of answers. If you take the class next semester, we'll go through this in more detail. But for right now, the Cliff Notes version is you get the Java file system for regular files, and that's actually what's being used here. Under the hood, the Java file system is being implemented by a Linux file system, and I forget exactly the details. It's in next semester's class notes. But it's basically a Unix-like file system that runs on flash memory. The database that's used, if you take it out of the box, is SQLite. And that would be for storing relational data or data that you want to be persistent that you can query on in a CRUD sort of way, where CRUD stands for create, read, update, and delete. And so that's the database you use. And there are also other third-party databases you can get in addition to SQLite. But this particular example is just using the Java file system. However, you have to do some funky things with permissions because of the way that Android's permission model works. And so if you really want to see the gory details of how that stuff works under the hood, take a look at the source code here. We won't talk a lot about this in this walkthrough because it's more about concurrency. But the app demonstrates how to do permissioning of files that are shared between different applications. And it also demonstrates how to do so-called dynamic permissions, which is a newer set of capabilities that Android has added in recent releases, where you can grant finer-grained permissions on the fly. It used to be that you had to grant all the permissions when the app started up. Now they give you more control over that. And if you run this app, you'll see it'll say, when you start up the app, do you want to allow files to be stored in the file system? Allow, deny, that kind of thing. So it's pretty straightforward. This stuff is very straightforward because they're just storing files. So this solution also has a pipeline, just like the one we looked at before that was the parallel streams version, except here, rather than the pipeline being sort of the classic streams, parallel streams, intermediate operations, and terminal operations, here we're going to be using something just a little different because we're going to be using some completable futures. And once again, this kind of demonstrates how you can mix and match streams and completable futures in a very clean and orthogonal way. So like the parallel streams variant we talked about last time, you can basically filter out images that are already in the cache, so you don't bother downloading them twice. So that's exactly the same as before. But then things start to diverge henceforth. So what we do is we go ahead and download any images that were not cached, but we do that asynchronously. And you can see here we just say map, and then we say download image async. And we'll look at this implementation shortly. But as you can imagine from the name, it's going to download the images asynchronously, and each of the calls to download image async will return a completable future. So we come in with a list of URLs as the input stream to map, and the output is going to be not a list. You come in with a stream of completable, a stream of URLs as the input to map, and you leave with a stream of completable futures to images that are in the process of being downloaded or will be downloaded. And then, so let's assume we have, just for sake of argument, let's say we start out with a dozen URLs and let's say 10 of them are not cached. So we'll filter out 2 of them. We'll get 10 URLs as the input to map. Map will return 10 completable futures to images that are going to be in the process of downloading once the wheels start to move. And then those 10 completable futures are passed into flat map to the apply filters async behavior, and then that's going to go and apply all the filters. And let's say, for sake of argument, there's 2 filters. So for the 10 images that come in, or 10 completable futures to images that come in, apply filters async will create 2 transformed images as output. That will come back as a stream, and then flat map will take all of those streams of streams and flatten them into a single stream of transformed images. But of course, that actually comes back as completable futures to all that stuff, because this is async. And so we'll have a stream of, in this case, 20 completable futures to images that are going to be downloaded and going to be filtered and stored. And then finally, what we're going to do here is, and that's different, of course, from the parallel streams version that we looked at before, because those were synchronously done, right? And then the final thing we do is we collect everything up into a list. So we'll end up with a list of completable futures to images that are being downloaded, filtered, and stored. So it's a lot of, it's a lot of lazy evaluation, and it's a lot of, doing things that are going to start up at some point but haven't quite started yet. And when you hit collect, that's when all the wheels start turning. So what you get back from this is a list of completable futures, and then we're going to go ahead and use a method called join all, which is a utility method that I use either standalone, as in this case, or you could use it, or pieces of it, to implement the futures collector, which is what you're doing in your current assignment, in order to be able to create a single completable future that waits for all the futures in the list of futures to finish doing their thing. So that's kind of joining everything back together again, and then we're going to wait for that to finish. So that's really, kind of the way this works. Now, if you really get curious and you peek around at the code that implements the ImageStreamGang, you'll see that there's 2 completable future implementations. One works like this, where we have a stream that collects a list of completable futures, and then we join them all and get back a single completable future. That's the one we're going to talk about. And then there's another implementation that uses futures collector, which is what you're using in assignment 3B. And that one doesn't have these 2 steps. It just uses a futures collector to collect everything. And if you run the app and test it out, you'll see that that runs ever so much faster than this approach. I'm showing you this approach just because sometimes it's useful to have this join all capability without using a futures collector. And so I'm just showing you how it works here. Okay, so once everything's finally done and all the images have finished downloading, transforming, and storing, at that point then a new activity is launched, and that's what actually displays the final images that you've downloaded. So that's cool. That's also more Android stuff. We'll talk more about that. If you take the class next semester, we'll talk more about how the Android stuff works. Right here, we're obviously talking more about how the concurrency stuff works. So what's the win? As usual, the ability to express your computations in a functional, composable-like way, cross-coupled with asynchrony, allows you to bring things closer from expressing the design intent without getting lost in the implementation details. Of course, there's lots of implementation details here, but this allows us to get closer and much more expressive, even though it's still a little wacky because it's asynchronous and there's all these, operations that are running in the background that finish with completion stage hooks and all that kind of stuff. Okay, so that's just a kind of a quick overview of what things look like from a high-level perspective about the various stages in the processing pipeline.